One lobe of an sp3 orbital is larger than the other because when atomic s and p orbitals combine, their wave functions add constructively on one side and partially cancel on the other, producing an asymmetric shape with more electron density on the larger lobe. Imagine you have one big round wave from the s orbital and three smaller directional waves from the p orbitals, and you add one of those p waves to the s wave to make an sp3 orbital. Where the peaks of the waves line up, they add together and make a bigger peak, and where a peak meets a trough, they cancel a bit and make a smaller peak. Electrons are more likely to be found where the waves add together, so one side ends up with more electron density and looks bigger. The math behind it is about combining wave functions and normalizing them so the total probability stays correct, but you can picture it like two overlapping ripples that sometimes boost each other and sometimes reduce each other. The smaller lobe still exists and affects bonding and geometry, but most bonding happens where the larger lobe points. Students often think both lobes are equal because pictures sometimes show symmetric shapes, and that can mislead you into ignoring the smaller lobe. Remember that pictured symmetry might be for a pure p orbital, not an sp3 hybrid. Another common mistake is thinking the larger lobe means all electrons live only there. The smaller lobe still holds probability and can influence interactions, so do not ignore it entirely. Some learners confuse constructive and destructive words with physical pushing and pulling instead of wave addition. Keep in mind these refer to adding wave heights, which changes probability, not physical forces. Visit www.gumballdegree.com to find more videos and resources on hybridization and orbital shapes.